Good day again, and welcome back to the Introduction to the Java Programming Language, a presentation of Coding Bootcamps. This is still Session 8, Defining Classes Using Inheritance. In our past two lessons in this session, we discussed the basics of how Java implements inheritance, and we also looked at abstract classes and abstract methods. In this lesson, we are going to look at protected class members. So Java provides a number of access modifiers to set access. So it's really setting visibility. So we're looking at visibility levels for classes, variables, methods, and constructors. So visible to the package, the default, no modifiers are needed. That is the default. Visible to the class only is private. So anytime we mark something as private, it is visible only to the class and members of the class. And then we have to instantiate the class, and we have to use the getters and the setter types of methods that we've discussed. Public is visible to the world, and then protected is visible to the package and all subclasses. So it's a little bit of a different variation of a private. So the default access modifier. So if we look here, there's no private or public here on the string version. So the default access modifier means that we don't explicitly declare an access modifier for the class, field, or method, etc. There's no private or public here for this method. So a variable or method declared without any kind of access control, without any kind of visibility, is available to any class member in the same package. The fields in an interface are implicitly public, static, final, and the methods in the interface are by default public. And private. So we talked about, we talked a little bit when we did encapsulation about private visibility. So methods, variables, and constructors that are declared as private can only be accessed within the class itself. So string format here can only be accessed by the members of class logger. So we can see here there's access here for set and get. Methods, variables that are declared as private can only, again, be accessed within the class. Variables that are declared private can be accessed outside of the class if the class is instantiated and the method is present to actually return, either update or return. In this case, that is the case. We can instantiate the logger class and then call set format and set the value of format. And then we can, again, instantiate the logger class and then call get format in order to return the value of format. Using the private modifier is the main way that an object encapsulates itself and hides data from the outside world. So again, we talked about particularly private data or private attributes or private variables when we discussed encapsulation. Public access modifiers or public visibility. The class, method, or constructor or interface declared public can be accessed from any other class. So we can call it directly. However, if the public class we're trying to access is in a different package, we must still import it. So we need to run those imports that we have looked at. Because of class inheritance, all public methods and variables of the class are inherited by its subclasses. And again, here is protected. So we can see here we have a protected method here, and variables, methods, and constructors which are declared as protected in a superclass can only be accessed by the subclasses in another package or any class within the package of the protected class member. So any other classes that are within the same package as audio player can access this method here, the open speaker. The protected access modifier cannot be applied to classes and interfaces. Methods, fields, and can be declared as protected. So we can declare methods, we can declare attributes or variables as protected. Protected access gives the subclass a chance to use the helper method or variable while preventing a non-related class from trying to use it. For our assignment, and we are going to go over this. You can see it here. This is going to have a few files, but we're going to have an abstract class dessert item. Then cookie, candy, and ice cream are going to inherit from our abstract class. The Sunday class is going to inherit from ice cream, and then we're going to create a checkout class to actually get totals and create something similar to a receipt that will output to the console. We will take a look at one possible solution shortly. And in this lesson, we learned about inheritance, superclasses and subclasses, the advantages of using inheritance. Again, the advantages really are reusability and quality, speed to market, protected class members, and constructors in subclasses. And we also talked about abstract methods and abstract classes. There is live private coaching available, and your learning material does have more information on these links. And thank you for watching this video. So let's take a look at one possible solution for our assignment. First thing we want to do is create that dessert item class. So what I did was I went over here and I created a dessert dessert project, Java project. I gave it a dessert package, and then I created a class called dessert item. And it is an abstract class. I declared it as an abstract class. We can see it right here. And in this case, I put 3 abstract methods. So you can see here that the abstract methods are they are setting what type of data these first 2 will take, and then what type of data will be returned by get items. Then there is candy, cookie, ice cream, and sundae. And what candy and cookie and ice cream are going to do is they're going to extend dessert item. And what I did was I added some variables for price and the number of items, and what they need to do is just make sure that they have all of the methods from dessert item. And what we are going to do is be able to set the price, return the price of each item, and also the number of items. And the same with cookie is structured in the same way as candy. It extends dessert item, and ice cream also extends dessert item. So they're very, very close. Then we have sundae here, which extends ice cream. So ice cream is right here, and sundae is inheriting from ice cream. Then if we go to the checkout class, this is going to be a little more complex just because we have to put all the business logic in here. It looks like a lot, but it's really not too difficult to understand. We talked earlier about static class variables, and I'm using them here just to cut down on the length of code. This would be a lot longer if we didn't use it. I don't think static is the best one to use, but in this case it works. I am declaring our candy object, our cookies object. I have candy, which is declared as a candy object of type candy, cookie, which is declared of type cookie, and that's the class. IC, which is declared as type ice cream, which is this class, and sundae, which is declared as the sundae class. And then I go through and I have the static variables for the cost and quantity and the tax information we're supposed to calculate in the checkout method here. Notice here in the constructor, this is where we are instantiating. So we're declaring and instantiating separately. We may be able to do them together, but I separated them here. But we do need to do both. If we don't do both, if we don't declare and instantiate, we're going to have we're going to get errors. And as you can see here, we're setting the number of dessert items, where we're passing in the number of each dessert, setting the number of items, and then we're getting a subtotal. So getting the subtotal returns the number of items. Then it returns the price for each item. Then what we're going to do is calculate the cost for each dessert item. So candy cost is the candy quantity times the candy price. Cookie cost is the cookie quantity times the cookie price. And same thing for the ice cream, same thing for the sundae. Then we do a sub cost. And we can see here we also have a clear method because they wanted us to clear. So clear just sets all of these class variables back to 0. And they also want us to calculate the tax. So what we're doing here is, now that we have the sub cost of all of the items, we can just go ahead and add in the tax amount down here. So what we're doing here is we're instantiating the checkout class, myCO object. We're creating that and instantiating our checkout class. We're setting the number of dessert items here. Then we're getting the subtotals. And we're adding in the tax amount here. So we're accounting for the tax amount. And the tax is declared up here. We can see that we have 4% tax. So we are calculating the taxable amount and then adding it back to the subtotal and then outputting everything just like a cash register. And at the very end here, we just want to validate that our clear still works. So we're going to look at the subtotal again, and hopefully it will be 0. So what we'll do here is go over to the checkout. The checkout is notice checkout is the only class with a main method. See, there's no main method in any, you could have one, but it could get confusing for us, so we'll avoid it for now. So checkout has the main method, and we're instantiating the other items through checkout. So let's right click, we'll do run as Java application, and we'll see the output, and we see here that we have we passed in two candies, 3 cookies, 4 ice creams, and 3 sundaes, and we got their subtotals, or we've got their individual totals. Then we have a subtotal for all 4, and we calculate the tax and add the tax to the subtotal. And then before we exit, we are going to make sure our clear works. So we call clear down here, and then we just test it by outputting the total again, and we see the total's been reset to 0. So it looks like it's working. So you do have the source code. However, again, please try as best you can on your own, but refer back to the example. And again, this is just an example. You might interpret the requirements in a slightly different way. That's fine. You can implement it a different way, but you have this source code to refer back to. So try the lab and stay tuned for the next lesson.